Hi, all. Good afternoon to everyone. Finally, we have discussed how to convert the given integer into words, and I asked you to solve the problem how to find the roots of a quadratic equation using functions. Given the inputs a, b, c, we need to print the result x1 and x2, and we need to print the nature of the roots. Now, let us solve the problem. Have anyone completed? Have you completed this problem finding the roots of a quadratic equation? Have any doubts in the previous session? Pooja, Kritika, Monisha, Badnashri, have any doubts? Have any doubts in the last session? Vigneshwaran,
No, sir.
okay. Now let us solve the problem finding the roots of a quadratic equation. Finding the roots of a quadratic equation. Assuming that the quadratic equation is ax square ax into x ax square plus bx plus c is equal to 0. We need to find the roots x1 and x2 and determine the nature of the roots. Let us include the header file hash include the header file is stdio.h. Then writing a main function into main. What are the inputs required? Inputs are the coefficients of the quadratic polynomial ax square plus bx plus c is equal to 0. So let us declare the coefficients as a floating point type float a comma b comma c, and a discriminant is required. So let us have the variable this. Initially input the coefficients a, b and c. Printf, please enter the coefficients a comma b comma c. Applying the inputs through the scanf statement. Scanf percentage f percentage f percentage f comma ampersand a ampersand b ampersand c. Inputs are obtained through the variables a, b and c. Next, let us define a function so that the function receives the parameters, that means the coefficients of the polynomial a, b, c, so that inside the function definition we can find the roots. Also we can find the nature of the roots, and we can display both, right, nature as well as the actual roots. So here, assuming one function, for example quadratic, this is a function, pass the parameters a, b, c, which are the coefficients of the polynomial. A, B, C are passed to the quadratic function. Let us define a quadratic function here. For example, void quadratic, return type is void, the function name is quadratic, then define the formal parameter list. Formal parameters are three floating point variables. Three floating point variables. Let it be float A, float B, float C. That means we are passing three actual parameters into this function quadratic. So three formal parameters which are also of floating point type. Even we have used the same name A, B and the C. So having this formal parameter list A, B, C, what is our next step? What is our next step in this computation? How to solve the quadratic equation? What is our next step? In unit number 1, please recall that we have already explored the quadratic.
Sir, you have to go with formula, sir.
Yeah, we have to go with formula, correct. So in the formula, first we need to find the computation. Since ax square plus bx plus c is equal to 0, formula, right, x is equal to minus b plus or minus square root of b square minus 4ac by 2a, in which b square minus 4ac, this is it to be the discriminant. Based on this discriminant value, let it be d, or discriminant is equal to b square minus 4ac. Based on the discriminant is equal to 0, discriminant is greater than 0, discriminant is less than 0, we have the corresponding nature. When discriminant is equal to 0, we have roots are real and equal. Discriminant is greater than 0,
With
we
length equal exponent.
distinct and real roots. Discriminant is less than 0, we have imaginary roots, right? Sai Bhargav, please mute yourself. Okay.
Sorry, sir.
Oh, it's okay. Now we need to find the value of discriminant. Discriminant, this is equal to b square minus 4ac. So based on that, we can uh, say its nature, root's nature. If you want to find the discriminant value, we can call another function. For example, in this program, let us define another function, float. A discriminant having the parameters float A, float B, float C. Simply, we do like to return the expression return b square minus 4.0 star a star c. You can ask, why should we define one more function? Since the function simplifies the complex task, if we have a complex problem, better we can split it into several sub functions. So if you like that, you can have a separate function to find out the discriminant. Otherwise, you can keep the computation in the same function definition, say quadratic. For example, the variable discriminant, this is not necessary here. assuming that here we are calling a function so that the variable discriminant is assigned discriminant okay discriminant a comma b comma c. So from the function quadratic we have called another function discriminant so that the discriminant is evaluated b square minus 4ac is evaluated and the result is assigned to the variable this. Now based on the value of this we can find right the roots of a quadratic equation. First, for example, we can control through simply write if statement. If discriminant is greater than 0, because this is one-time computation discriminant from which we can have three clues. If discriminant is greater than 0, equal to 0, or less than 0. Three clues. First, checking if discriminant is greater than 0. If it's so, we need to call or you can print right the result here itself. For example, I print the result. Print slash n roots are real and distinct. That means we have two different roots, real and distinct. In this case, we need to find out the values of x1 and x2. So when discriminant is greater than 0, dis discriminant, this is greater than 0, we can find x is equal to minus b plus or minus square root of b square minus 4ac by 2a as x1 is equal to minus b plus square root of b square minus 4ac. Since this is stored in a variable this, here use this divided by 2a and x2 is obtained. X2 is equal to minus b minus square root of discriminant by 2. So two real and distinct roots x1 and x2 are obtained. Real and distinct roots. We have given the message printf slash and roots are real and distinct. Then find the computation x1 and x2 accordingly. So to find out x1, x2, have the variables say x1, x2 floating point variables. Here find it x1 is equal to what is our computation minus b plus square root of discriminant by 2a minus b plus for square root we can call a function sqrt and include a header file math.h minus b plus square root of discriminant dis. This would be divided by the denominator which is 2.0 star b. This is the value of x1. Then x2 is computed. X2 is equal to minus b minus square root of discriminant. This will be divided by 2a. x1 and x2 are computed. Then we can call a print function, right? If you want, you can pass the parameters x1 and x2 where x1 and x2, right, may be printed. Or here itself we can print first x1 is equal to percentage f comma x1 slash n. Then x2 on space I left, x2 is equal to percentage f comma x1 comma x. x1 and x2 are passed to the percentage f's specified in the printf statement. So first root is obtained minus b plus square root of discriminant by 2a. Second root is obtained minus b minus square root of discriminant by 2a. x1 and x2 are printed in this function itself. Second, else if discriminant is greater than 0, condition fails. Suppose discriminant is equal to 0, here if the condition fails. Assuming that discriminant is equal to 0, putting the discriminant value b square minus 4ac to 0 in this equation, star, we have x is equal to minus b plus or minus square root of 0 by 2a. So please understand this is equal to minus b by 2a. That means plus or minus 0. So we get a minus b plus 0 by 2a minus b minus 0 by 2a. So it seems the results are real and equal. Here we have the nature as roots are real and equal. Both roots are same. x1 is equal to minus b by 2a. x2 is also equal to minus b by 2a. We can write separately x1 is equal to minus b by 2a, x2 is equal to minus 2 by 2a, or even we have the multiple assignment statement. x1 is equal to x2 is equal to minus b by 2a. Now what we have to do, we need to print this message. Our roots are real and equal, and find the computation of x1 and x2. So else, assuming the discriminant value is equal to 0. Here, first provide a message printf slash n roots are real and equal. How to find x1? x1 is equal to minus b divided by denominator 2.0 star u. Then x2 is also the same result. Even you can write in a single assignment statement. Say x2 is equal to x1 is equal to minus b divided by 2a. How it is evaluated? Minus b by 2a, this is evaluated first. This result is assigned to the variable x1. Then the value of variable x1 is assigned to the left-hand side variable x2. This way, both variables x1 and x2 are assigned the same value. Then we can print the result. Printf slash n x1 is equal to percentage f, then x2 is equal to percentage f, comma x1 comma x2.
Else if should be there, right?
Yeah, else it, yes, it is. Even right, we have right the same printer statement here. One more time, the same printer statement is there. We can also make it in a function, say print result. Simply call print result of x1 comma x2 so that the result will be printed in the printer function. Or if I use print underscore result, values are x1 comma x2. This can be cut here, edit, cut, define a function void print underscore
Sir, can we
result.
do the steps in the main function? I mean main system, sir.
Pardon? What is the doubt? Yes, tell me.
In the when we are calling the function there, we can write if print x1 and x2, no, sir.
Yeah, when calling the function, yeah, we can print x1 and x2. So that's what I need. This is a function. So that x1 and x2 are passed to this print underscore result. That's what here, right? We are writing a function. Void print underscore result. I need to put a shift ensure. The result is printed here. So that here also I can make the same function call print underscore result x1 comma x2. Thus we are simplifying the task by defining a function because a function can be called any number of times. So logically here we have defined the function print underscore result. Just to print the result. What is x1 and what is x2. So one time right we can write a function. The function can be called any number of times. Here so far we have called twice to print the result x1 and x2. Clear? Manasa, have any doubt?
No, sir.
It's not necessary, right, to have this kind of separate function. If you want, we can write as I did
No,
earlier.
sir. We will be calling the quadratic function in the main function now, sir. Like where
Yeah,
we
here we have called. Yeah, here we have called.
in there like next sentence, can we just write print x1 and x2? That was my question.
Yeah, if possible, here write uh, here itself, right? You can print the result x1 and x2. But this x1 and x2 cannot be printed following this function call. Why? What is the reason? Following this quadratic function, for example, here I have highlighted. This in this place we cannot print x1 and x2. Why? x1 and x2 are local variables with respect to this quadratic function. So these local variables cannot be accessible within the main function. So that's what here, right? If you want, you can print the values of x1 and x2 here itself. Otherwise, define a separate function and pass the values of x1 and x2 and print the result here. Hope you understand.
Yes, sir.
Else, if another possibility, right? Else, so when these two conditions fail, discriminant is greater than 0 and discriminant is equal to 0. Ultimately, discriminant is less than 0. That means b square minus 4ac. This is less than 0. In this case, x is equal to minus b plus or minus square root of b square minus 4ac by 2a. Here the term square root of t square minus 4ac, here we have a negative quantity. We cannot take a square root for the negative quantity. So multiplying this result by minus 1. This is stored in a variable discriminant. Multiply this result by minus 1 so that we have minus b plus r minus square root of minus discriminant by 2a. In this case, we cannot say this is the real part. So here we need to separate the real part and imaginary part. So real part minus b by 2a and imaginary part is minus square root of, not minus, square root of minus discriminant by 2a. To have the actual solution, we need to combine both the real part and imaginary part. Say real part plus I into imaginary part and the real part minus I into imaginary part. So here the roots are imaginary roots. B square minus 4ac is less than 0. Roots are imaginary. Let us see how to convert this computation. Minus b plus r minus square root of minus discriminant by 2 into two parts, separating real part as well as imaginary part. Here see else discriminant, this is equal to 0. Sorry, discriminant is less than 0. In this part, printf slash n roots are imaginary. So finding the roots separately, right? What is the real part and what is the imaginary part? Here, real part is minus b by 2a. Imaginary part is square root of minus discriminant by 2a. Here, declare the variables, for example, float, real, and image. Finding the value of real part, real is equal to, what is a real part? A real part is minus b by 2a. So write a C statement, minus b divided by 2.0 star a. Then imaginary part is equal to square root of minus discriminant by 2a. So writing square root concern, square root of minus discriminant by 2a. Because discriminant is negative, we cannot take a square root. To make it a positive one, discriminant should be negated. Minus discriminant. What is the role of minus here? What is the role of minus here? What is the role of minus in minus discriminant? This is unary minus operator, just negates the variable discriminant. If it is minus 5, then this becomes minus of minus 5 and plus 5. Square root of minus discriminant, this will be divided by, right, again the expression 2.0 star a. So real part and imaginary parts are obtained here. Then we need to print the results, real part and imaginary part. For example, here we can print the result separately, real part as well as imaginary part. Here we cannot call this one because x1 is actually real part plus I into imaginary part, or you can print logically print of slash n x1 is equal to percentage f plus percentage f first takes real, second percentage f replaces a variable image. Here put I, or put here I, percentage f I. Say real is 2, imaginary part is a 2.5. It seems so 2 plus 2.5 I. Imaginary part, right? It may also be a negative one. So if it is a negative one, you need to have the sign. For example, for 2 plus minus 2.5 I, or simply put the value imaginary part within the parentheses in case if you have a negative value of imaginary. It seems so 2 plus within bracket a minus 5.2 I. So that means a 2 minus 5.2 I. Otherwise, further check the sign of image. Image is positive or negative. If it is negative, right, print a value using minus. Otherwise, print the value using a plus. This is one result. Then second, print of slash n. We need to print a value x2. X2 is equal to percentage f plus not plus, right here minus real part plus I into imaginary part, that is x1. This is x1. Real part plus I into imaginary part. Then real part minus I into imaginary part. This is x2. So I am printing x2 here. Percentage f minus. Then within bracket percentage f, I put I to signify separately the real part and imaginary part. So write the variables real comma image. So this is the case only when the roots are imaginary. Otherwise, you can call the function a print result so that the parameters x1 and x2 are getting printed inside the corresponding print result function. Now this is the case when the roots are imaginary. Let us close the first function, void quadratic. Then this is the second function, say discriminant, and this is the third function, print underscore the result. Now let us check the result here. Include the function prototype. What are the function prototype?
Sir, math.h also we have to include now.
Yeah, math.h. Yeah, very good. I forgot it. Okay. Hash include math.h. Good. Then define the prototype function prototype. Shift end edit control insert, then edit shift insert, put a semicolon. Likewise, the remaining two functions, float discriminant, float A, float B, float C, edit, copy, scroll up. After this, say edit, paste, put a semicolon at the end. Then printing the result x1 comma x2, edit, copy, so edit, paste, put a semicolon at the end. Have you missed any other things? To wrote discriminant x1, x2. Okay, real and image are locally declared here. X1, x2. In case if you want to avoid the variables real and image here, even you can use the variables here. For example, x1 and x2. x1 is equal to minus b by 2a. x2 is equal to. But logically here, real comma image should be changed into x1 comma x2. So that additional variables are going to be eliminated. Now let us check the result. F2, F9. Yes, the program finished its compilation. Zero errors are reported. Control F9. Let us input the values. For example, x square plus x square plus 3x plus 2 is equal to 0. So 2 is factorized into 2, 1. So multiplication that results into addition, right? 2 plus 1, 3. So factorizing this, we have x plus 2 into x plus 1 is equal to 0. So we are expecting x is equal to minus 1 and x is equal to minus 2. So provide the coefficients here as ax square plus bx plus c is equal to 0. Comparing this one with the given quadratic polynomial, we have a is equal to 1, b is 3, c is 2. So check the result by providing 1, 3, 2. 1 space, 3 space, 2. Our roots are real and distinct. x1 is minus 1 and x2 is minus 2. We are getting the result x is equal to minus 1 and x is equal to minus 2. Okay. Then have another one. Suppose x square plus 10x plus 25 is equal to 0. So 25 is split into 5 and 5. Multiplication results in 25. Addition results in 10. So this is simply x plus 5 into x plus 5 or x plus 5 whole square is equal to 0. Having the real as well as equal roots. X is equal to minus 5, x is equal to minus 5. Now provide the coefficients. A is equal to 1, B is equal to 10, C is equal to 25. 1, 10 and 25. Control F9, second run 1, 10, 25. Roots are real and equal. x1 is minus 5, x2 is also minus 5. Then have the third one to include the imaginary roots. Suppose 2x square plus 5x plus 1 is equal to 0. Find discriminant square root, find b is equal to b square minus 4ac. b square, right? 25 minus 4ac, 4 into 2 into, suppose this is 4, minus 4 into 2 into 4. And now what happens? 25 minus 8 into 4, 32. So d is equal to minus 7. Having this, a is equal to 2, b is equal to 5, c is equal to 4. x1 is simply minus b by 2a minus 5 divided by 2a, 2 into 2, 4, minus 5 by 4 minus 1 time, then 0.25 minus 1.25, then x2 is equal to the imaginary part, right? Square root of minus d minus 7 divided by 2a. So we need to evaluate square root of 7 by 2a. 2a is 4. We will get, this is the real part. This is the real part. This is the imaginary part. And we need to print the result. X1 is equal to real part plus I into imaginary part. X2 is equal to real part minus I into imaginary part, where I is equal to square root of minus 1. Let us check the result by providing these inputs 2, 5, 4 to have the imaginary roots. 2, 5 and 4. Control F9. 2, 5, 4. Roots are imaginary. Yes, after this computation, we have x1 is equal to minus 1.25, because real part is minus 1.25, that is printed here, minus 1.25 plus imaginary part. Imaginary part is actually square root of 7 by 4. Square root of 7 by 4 is evaluated and the result is printed here, 0.66. And I have printed the value, right, I at the end. IP, imaginary part into I. So it seems imaginary part into I. Then x2 is minus 1.25 minus this one into I. In case the imaginary part is a negative one, right? Here, imaginary part, square root of this one. Okay, for minus thing, minus imaginary part is square root of this one divided by 2a. So square root of positive quantity by 2a, always a positive one, so no problem. Here we can have the result like this: a plus ib. A is the real part and b is the imaginary part. So real part plus I into imaginary part. Have any doubts in this example? Have any doubts? If you have any doubts, you can ask now. Shall we move on to the next problem?
Yes, sir.
Okay, please save this one. And coming back to the previous problem, I think give an integer into votes. We have used the reverse logic, and then we have processed through the switch case statement to print the result. Or if you don't want to reverse the number, you can extract the digits one by one, and you can store the digits in the array. From that array, right, you can easily print the equivalent digit into votes. For example, I like to modify the same, so that in case if your input is 100, 100, 100, you can expect the result as 100 in votes. See how to modify the same code. File, a new, edit, paste, have a file name CP57, CP57, digits into votes, Okay, here enter n, okay, or scanner, no problem. There is no change here. Here we don't want to uh, find its rewards, so I remove this for loop, shift delete. Reverse is not required, so I have deleted that. I define a local array, for example, intakes of 10 or intakes of, okay, 10, right at the maximum to store at 10 digits. Just to go through the for loop, right, and find the reminder and store the result into the array X. For example, for have the while loop, while what is our input when n is greater than 0. We need to update the array elements. Initially, for example, int x of 10, I use one index say j is equal to 0. I update a value of x of j is equal to, let us find the operation n mod 10. Suppose n is 123, n is right 123, say n is 123, 123 mod 10, 3 is extracted, and we are storing this into the zeroth location in the array. So it seems x of 0 is equal to 3. So to write that x of j is equal to n mod 10, since j is 0, yes, it's clear, x of 0 is equal to n mod 10, x of 0 is equal to 3 is assigned. Then 123, this is divided by 10 further to have a result 12. Next stage 12 mod 10 should be performed. The result 2 should be assigned to the next location in the array. X of 1 should assign a value 2. So writing the operation n is equal to n by 10, and the variable j needs to be incremented by 1, j plus plus. This is right similar to just to think of how we have introduced the variable j and j plus plus in decimal to binary conversion. Same way here we use j plus plus. So next here after j plus plus, j plus plus, j becomes 1, since initially j is equal to 0 here. This 0 is nothing but x of j. Hope you understand. This is again x of j, where j is 1. X of j is equal to next value, that is n mod 10. Currently, right, n is updated to, because of n is equal to n by 10. N becomes 12 here. 12 mod 10 or 2, x of j is equal to 2 is assigned. Then n is equal to n by 10, having another operation, n is equal to n by 10, 12 by 10, that results in 1. Next, n mod 10, j plus plus, after j plus plus, n mod 10. N mod 10 means 1 mod 10, this results in 1. This is further assigned to the same statement, x of j is equal to n mod 10, 1 mod 10, 1. The index is right, because of j plus plus, x of 2 is setting a value 1. Next, n is equal to n by 10, n is equal to 1 by 10, this results in 0. Before that, j is right incremental. Before checking the condition, I mean j plus plus, j is pointing the index 0, 1, 2, I think j is pointing the next index 3. But we don't have right anything to be assigned in the third index because current n is 0. Next control enters into the while loop while n greater than 0. 0 greater than 0 condition false. Control comes out of while. so that as he processed, similar to decimal to binary conversion. Current j is 3. Let us start at j minus 1. J starts at j minus 1. That means j is equal to 2, j is equal to 1. Still j reaches 0. We need to process the values x of j, that is x of 2, x of 1, x of 0. X of 2 is 1, x of 1 is 2, here x of 1 is 2, then x of 0 is 3. So process the reminders, right, stored in the array x in the reverse order. J starts at j minus 1. Shall we have the operation here using a for loop for j is equal to j minus 1. I write j is equal to j minus 1. Then j should be greater than or equal to 0. Then decrement the value of j by 1, say j minus minus. Taking the for loop, what we have to do, take a value of right x of j and print x of j. So this while, right, I am removing this while. Carefully check opening and closing curly braces. Okay, switch R mod 10. Instead of R mod 10, what needs to be put here? We need to put, can anyone tell me what we have to put inside the switch? X of 2. X of 2 is already assigned the integer 1. Next, x of 1 is already assigned the integer. X of 0 is already assigned the integer. So what happens when you put the expression? Can you tell the expression here? What needs to be replaced in the question mark? Yes, tell me. What you have to replace in the question mark? The digits are right processed in the array starting from the index right j minus 1 in the reverse order. So question mark is replaced by what one? X of j, and j is equal to j minus 1. X of j, right? The value is taken to switch x of j. That means based on the value of this x of j, control goes to execute, right? The case statements, case 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There is no change in that. Then what we have to make next? R is equal to R by 10. This should be eliminated. Switch opening curly brace, closing curly brace, then for opening curly brace, for I think ends here, for closing curly brace. For ranges from j minus 1 to 0 in the reverse order. Then a printer slash n. Okay, I think that is to process for the next input. That's all. Let us include the necessary variables and check the result. What additional variables are required? In our case, j declared here, x declared as the array type, j minus 1 x of j. Okay, let us check the code. F9, control F9. Now check the result. I think I have not printed the actual integer. In case if you want to print the integer, where you have to start uh, while n greater than 0, We need to print the value of n first here. For example, here I like to print slash n percentage d comma n. N is printed colon. I leave some space or colon. Control F9. Check if you have obtained the correct result. 1 colon 1 2 2 3 4 5 6 7 8 9 10, right? It should be printed as 1 0. 11 1 2 1 1 12. Okay, then check for some numbers, say 50 5 0 60 6 0 70 8 0 90, right? 90 9 9 8 9 9 100, right? 100. We are printed the results, right, in the correct way. Have any doubts in this example? Simply we have used the local array to extract the reminders. The reminders are stored in this array. How we have processed the reminders in decimal to binary conversion. The same way, while n greater than 0, we have iteratively performed modulus 10 operation, and the reminders are stored in the X array. Then based on the reminders stored in the array X, we need to process it in the reverse order. Rj starts at j minus 1 because in 1, 2, 3, first 3 is stored in 0th location, then 2 in the first location, then 2 in the, 1 in the second location. We need to print the array values, right, in the reverse order. So x of 2, x of 1, x of 0. Current j is incremented by 1. J is pointing the third location, but we made the assignment, right, up to the second location. So decrement the value of j by 1. J is 3. 3 minus 1, 2. Then j is 2. Find the value of x of 2. So j starts at j minus 1 till j greater than or equal to 0, right, remains 2. J minus minus. Extract a value of x of j and print the equivalent in rows. So case 0, case 1 up to case 9, there is no check needed. After this, the current number has been correctly printed with respect to the words equivalent. Then this slash and forces the output, right, to bring it into the new line so that the next input will be printed in the new line. In case if your input is n is equal to 1000 up to 1250, file save, control F9, you can see the result. Here some outputs are right already skipped here, but the results are gone right out of this output window. So 1051, 1052, 1130, right, finally 1250, 1250. The output is shown like this. Hope you understand this example. Similar modification in the previous program, so that whatever is the input, 1000, right, even we can expect a value 1000. 1 sorry 1 0 0 0 F2, control F9, yes, 1000, right, 1 triple 0. Loss value 1050, 1050. Have any doubts in this example? Any doubts? Vignesh, Jayashakti, Manasa and others.
No doubt, sir.
Okay, I post the materials right after some time. Please go through it. I tell you the syllabus right once it have been fixed. Prepare well for the test. Okay, thank you very much.
Okay, sir. Thank
Thank
you.
you, sir.
Thank you, sir.
Thank you, sir.